Hi, everyone, and thank you for joining us today. My name is Nicki Catchpole, and I'm a senior analyst at TBR covering cloud and related technologies. And I'm very pleased to be joined today by Rob High, CTO for IBM Edge Computing. Welcome, Rob.
Excellent, Nikki. Thank you so much for having me here today.
I'm especially excited to have Rob join us today to add to the enterprise edge market landscape that TBR pulled together across practice groups, augmented by the input from our vendors, IBM being one of the featured vendors and founding members of this latest piece of TBR research. So, Rob, just to start, in general, just as the world, it seems, has finally gotten its grasp on cloud computing and what it means in the overall context of digital transformation at large. And now all of a sudden, everyone, it seems, have started to talk about the edge. Before diving into a couple of examples and going in depth into the benefits and challenges, could you briefly touch on the evolution of how we got to where we are today in the discussion of edge?
Yeah, because it's interesting. If you look back at our history in this information technology industry, you begin to see certain patterns, and one of the patterns that's been quite clear is this pendulum between sort of centralized computing and distributed computing. And it started with, of course, the mainframe. Everything was centralized on a single computer, and you kind of went to it for whatever work you needed to get done. Later we saw things like client server emerge, which was an attempt to take advantage of all the sort of personal computing that was coming onto the market back in the 80s and early 90s, and where people wanted the enterprise organizations wanted to take advantage of that compute capacity, and move some more of the workload out into these desktop and later laptop machines. And one of the things that they encountered, of course, was it turned out to be quite difficult to manage that, to administer getting all the right software at the right place at the right time. Later, the internet was born, and we all kind of retrenched back onto this sort of centralized compute model, using the internet and web-based applications that centralized a lot of compute capacity that we typically wanted to expose to our end users. Then we saw the emergence of mobile computing and the use of mobile devices, smartphones, of course, laptops, and the advent of, I'll call it the App Store. Generically, of course, the Apple App Store, also the Google Android Play Store, and people got their workloads by downloading them as apps into their mobile phones. But then we saw the emergence of the cloud, which became a great way for businesses to centralize some of their mission critical work and to get better economies of scale and utility by centralizing on other people's central compute capacity, that is the cloud compute. And so now we're seeing that pendulum swing one more time. And I don't think that this is necessarily a swing in the sense that edge computing now replaces cloud computing, but rather that I think it's a complement. And it's a complement in much the same way that we saw with mobile computing as well. Very little of the mobile compute applications out there actually operate without being tethered in some way back to a cloud for provisioning, for centralizing information, et cetera. And I think the same thing is true here. But the difference being that there's an enormous growth in what I call software-defined products on the marketplace today. These are things that are used in factories and hotels and retail stores, whether those are intelligent cameras or intelligent turbine engines or even intelligent vehicles. These are all examples of product who get the majority of their feature and function value unlocked by the software that is hosted on that device. And of course, the rationale behind doing that is not only does it add new value to those devices, but it also harnesses the benefits that come from lower latency interactions, decision making, and of course, with all the networking that's needed, all the data that's being generated, getting better handle on efficient use of the available network bandwidth.
So I think that will come as a comfort to many of the organizations who have invested a lot of time and energy in deciding or to adopt the cloud, or at a point where they're seriously considering that they haven't been down some wrong path that's no longer relevant. When you think about an enterprise that is poised and ready to adopt edge, is there a point of criticality at which you think that their journey within the cloud, that they have to reach a certain point? Or do you think that both can kind of be done and adopted in tandem?
Yeah, I mean, so first of all, we define edge computing as being about placing workloads closer to where the data is being generated, which is another way of saying where the users are. Because frankly, when you think about the production of data, it begins with us as people. We're the ones that are actually creating the data. It's either we're entering it, as a reflection of things that we're doing, or it's coming from the environments in which we operate. And it's us that these computers, in the end of the day, are serving to help us make the better decisions. So when you think about that, you begin to realize that there's a lot of utility in moving workloads to where that data is being produced, to lower latency, to increase bandwidth, or to get better efficiency out of bandwidth, and to be able to maintain better resilience and secure private and public, private and personal information. But the, the fact that we're moving workload closer to the user does not invalidate any of the advantages that have come from cloud native development practices. In fact, what we typically see are institutions who have been spending the last X number of years developing cloud native applications. And we can now take the principles of cloud native development, which includes, microservices and segmentation and separation of concerns and componentization and, continuous integration, continuous development, DevOps, and agile development practices. The idea that you can take all of those practices and capture them in a container in the cloud is an idea that we can now leverage when we come to the edge. It's not necessary to go invent or build skills around a whole new style of development. In many cases, it's taking the work that was already been done and now beginning to think about what would happen if I took the containers I just put into the cloud and now make that container available close to where the data is being generated and where the action is being taken. Would there be an advantage that comes from that lower latency or better bandwidth control that still realizes the original intent of the application, but in some cases, for those components that matter, are able to realize that in a better and more effective way for the end user? So in many cases, these journeys to the cloud, are not being disrupted by the introduction of edge. They're really kind of the next logical step when you come to realize that there are certain things that you could do by placing that same workload closer to where the people are.
Edge compute is, of course, a relatively new technology compared to others, and one that has garnered a lot of attention and questions in general. Rob, what would be your advice to any organization contemplating the edge in terms of criteria, as well as the business value, if done correctly, that one can expect to receive? It would also be great if you could highlight some of those use cases, because we really find that that's what brings it to life.
Yeah, well, I mean, look, the first thing to do is stay grounded in your business objectives and the business value that you're trying to deliver. I personally would never advise adopting a technology without understanding how that technology advantages the outcomes you're trying to achieve from a business, because that's, at the end of the day, what we're all here for, is to serve our clients and end users and help them get done the things that they need to get done. So begin there, but in that process, as you begin to realize the unique advantages that edge computing can bring to that, realizing that business value, and in some cases, it's almost an imperative. I mean, think about a vehicle that has visual analytics running on it to recognize when a ball runs in front of the vehicle that, maybe there's a kid right behind it. You need to stop this car now, apply the brakes. That's a decision that needs to be made in milliseconds. If you were to try to do that visual recognition in the cloud, and make a call from the vehicle up to the cloud to take this image and do that analysis, by the time the decision is made, by the time that it's realized that there's a kid running in front of the car and you've now activated the brakes, that could be too late. There may be other cases that aren't quite so egregious, but yet still where very quick time to decision making is particularly important. If you're a manufacturer and you're trying to to examine, again, using visual analytics or perhaps acoustic analytics or some other technique for recognizing the quality of assembly work that your machines are doing, and you're pumping out 100 or maybe more parts per minute. You only have a few milliseconds to decide whether that weld seam or that joint was formed properly before that part now is moving on to the next stage of your manufacturing process. So again, milliseconds matter here, latency matters. Another case, that's worth examining is one where, there's a lot of scenarios where what you're trying to do is recognize things. And I'll give you a good example. This is a discussion we had with a manufacturer. One of their problems is they lose parts on the manufacturing floor, right? A worker, puts a part down and forgets about it, and it gets lost, or parts get sent to the wrong station and not returned. Parts get lost on the factory floor. And so what they do today is they send out a team of people. They run up and down the aisles of the factory looking for these lost parts, collecting them, or bringing them back. What they would like to be able to do is, deploy an array of video cameras across the factory floor that are, simply trying to recognize and identify these kinds of lost parts and identify where they are, so that they don't have to randomly send people out. They can send people out to the very specific place where they know these parts might be lost. Well, so that requires video analytics. And again, the video processing can be done in the cloud or some central location. But if you've got, 1,000 cameras arrayed across your factory looking for these parts, and you've got a 4K video camera, I mean, that generates a 50 megabit per second video stream. Now it's 20 megabits if it's compressed, which is fine, but still it's 20 megabits per second of video data being generated. And, it only takes a few hundred of those kinds of cameras to completely saturate your network. So instead, what they like to be able to do is move the video analytic out onto the intelligent camera itself. So that's just another example of where edge computing can benefit the outcomes that you're trying to generate. And so in those cases, the analytic that you might have already been building and constructing for running in your cloud now becomes a candidate for executing, in this case, on the video camera itself, or perhaps in some small server that is attached to that video camera, and does the job just as well. And the only thing you're really sending back to the cloud is the coordinates of where that part was found and identified. Look at the use case, look at the business that you're trying to achieve, and then start to make decisions about the placement where you want to put these pieces in the cloud versus in the edge.
Okay, now with all of the benefits in mind that you've outlined, focusing specifically on latency and longer term analytics, can you also speak to the flip side of the equation around some of the challenges and some of the hurdles that any organization may expect to encounter as they adopt edge computing as part of their operations?
Well, that's right. So, to follow up on your previous question, what are the problems that you might run into? Well, there are some issues with edge computing. The number one is scale. As I just got done describing, I mean, you might have 1,000 video cameras arrayed across your factory floor. And in fact, it may not even have the same analytic on it. It may have different analytics. You may have different cameras looking for different things, and therefore have to have a different machine learning model associated with them. You might have assembly machines with compute capacity in them. You might have conveyor belts or stackers and sorters, or if you're in a retail store, you might have point of sale terminals, or even robots that do inventory tracking or even restocking. In this emerging world of intelligent retail, you might even have intelligent shopping carts that when you put a product, take a product off the shelf and put it in your shopping cart, it registers the fact that you now have taken that product. And all of these, are valuable places to put work. But when you got a lot of them, you have to deal with how are you going to manage that? How are you going to get the right software at the right place at the right time? But on top of that, how are you going to keep up with all the changes that occur? I mean, these things move around, they get repurposed, they get reconfigured. You may be dealing with a lot of diversity, different machines with different architectures and different amounts of memory and storage and peripheral devices and sensors and again, purpose. So, and then of course, there are security threats that you have to be aware of. I mean, a lot of these devices are out there in the wild, and in the retail store, in the presence of a whole lot of people walking around in that store, or even on the factory floor, or in the distribution centers, et cetera. And so, there are a number of problems that start to surface in edge computing, and that's what we have been concentrating on in IBM, is how to help people manage the deployment of their workloads, of their software to these devices, making sure that we're able to recognize the differences between each of these nodes and accommodate those differences, making sure that we've got the right version of software out there at the right place, the right version of the machine learning model out there at the right place, and that all of that is being handled at scale with security and recognizing the diversity and dynamism of those environments. That's what we call autonomous management. The system that we've put together based on the Open Horizon open source project is really designed to handle that kind of complexity at massive scale.
With all of those said benefits, but equally recognized challenges in mind, can you speak to the approach that IBM has taken to help facilitate the customer journey to the edge and the types of solutions that are currently being offered?
Yeah, so the IBM Edge Application Manager has a management hub, and that management hub needs to be installed someplace. We run as a clustered Kubernetes workload running on top of Red Hat OpenShift. So wherever you can place OpenShift, you can place the management hub. That might be in your IT data center, it might be on your factory floor, it may be in the IBM cloud, it could be in any of the hyperscale cloud providers as well, including Amazon and Microsoft and Google. So you place that management hub as a clustered solution or clustered application in any of those locations where you might want to run OpenShift. And from there, now you can manage the deployment of workloads out onto both clusters as well as devices in your edge locations, your remote on-premise edge locations. We do this in a way that does not require that you to break down your firewall. We go through normal HTTPS communication, and all communications initiated from the edge, so that you're not having to do anything unusual there. But we do so in a way that is both autonomous, as we've described before, but also very secure. And then in that process, not only do we manage the deployment of the workloads, but then we allow you to monitor those workloads so that you can keep track of where work has been placed, what work is up and down, what work is is actively being utilized. All of that kind of monitoring information is also accumulated at the management hub, so that you have awareness of the decisions that were made and where work is being placed.
Everyone always wants to know about the future. And of course, no one has the answer to exactly what's going to happen outside of our control. And seeing as the environment in which we're operating in today, there's clearly nothing more true than that. That being said, in the absence of a crystal ball, Rob, what would you predict to be the major developments that will occur in terms of industry and scale of major adoption of the edge over the next 5 years?
Yeah, so look, I mean, we have found use cases in virtually every industry that can and are benefiting from edge computing. I mentioned manufacturing quite often just because it's a simple and obvious example, but we're also seeing this in automotive, as automotive manufacturers are going through the process of re-architecting their vehicles and taking advantage of the compute capacity that exists within those vehicles. We're seeing this in retail, especially within retail stores, where people may be getting more efficiency in addressing spillage and spoilage and loss prevention, increasing and improving the user experience and so forth. We're seeing this in hospitality, and especially as hotels begin to transform their guest experiences. We're seeing this in distribution and logistics. We're also seeing this in banking to some extent, as well as in energy and utility. So every industry we can find examples of where edge computing has a potential for lending value. I think the thing that's motivating, the reason that I think the crystal ball perhaps is not as muddy as it might be in many other cases, is because we're already seeing the trends. We believe that there are around 15 billion edge devices in the marketplace already today. And by edge device here, I mean any piece of purpose-built equipment that has embedded computing and uses software as a way of unlocking the features and value of that equipment. Of course, edge clusters are also quite numerous. We believe that grows to probably around 55 billion devices by 2022. And we've seen estimates that indicate that it could be as many as 150 billion devices by 2025. So, irrespective of what we're doing in IBM, the fact is that more and more equipment and devices and product that is being manufactured and delivered into the marketplace has compute capacity in it, and it lends then the question of, well, how are you going to manage it? How are you going to manage getting the right software to the right place at the right time? So I think, technologically, we're in the right place to help customers address, as you said, the fire that they have to get through to get there. But the fact is that the motivation for using the compute capacity in these devices and harnessing that to bring advantage to their businesses is quite strong. And I think that's going to carry a lot of inertia. Add to that, then, of course, the emergence of 5G as a networking protocol, which further reduces the latency, but also increases the potential to integrate these kinds of devices through, wireless connectivity. That today is still a little bit lacking, but as we get 5G networks rolling out, we'll certainly accelerate the adoption of 5G in many of these industries.
Oh, Rob, that's great. And it's really sessions like this that selfishly give me newfound confidence in my ultimate job security for pretty much the rest of time, because there seems to be no end to the amount of things to speak about, to highlight when it comes to this new and emerging technology that really has only seemingly come into people's nomenclature and dialogue within the past couple of years. So thank you on behalf of TBR, and I know our listeners, for helping us shine some light on this, and especially with the use cases.
Absolutely, Nicki, and thank you so much for having me here today.